Today, I want to go over some of the details of the problem that we had yesterday, in which I gave you the rate at which water was removed from a tank, which means I gave you the middle function. Then I asked questions about the derivative of the given function and the antiderivative of the given function. So I want to talk about the details of this today. So here we're looking at the setup that we're looking at is that there's a function, then rate of change of the function, and then the rate of change of the rate of change. We're given the function in the middle, and I ask questions about the definite integral and about the derivative. So the first question that I asked about was r prime of t. I said calculate r prime of 2. Now the interesting thing about what's going on here is that we have to estimate what's going on at 2. So in the first problem, I wanted to calculate r prime of 2, which is going to be the slope of the tangent at x equals 2. Now, the problem with these questions is that, the first two questions anyway, is that I did not tell you what was going on at 2. So there is a missing piece of the graph. So we don't have information about what's going on at 2. That's why it said estimate in all these problems. We don't know what's going on at 2. We do know that r of t is decreasing and differentiable. So there's no funny business going on at 2. It doesn't go from 1190 at 1, jump up to 1,000 or 1,000,000 at 2, and then drop down to 950 at 3. All we know is what's going on at the endpoints. So what's going on at the endpoints is that at 1, we're at 1190. And then later on at 3, we're at 950. We don't know what's going on in between. We just know we decrease from 1190 to 950. So we're going to estimate what's going on. We know things are changing. We're going to apply the simplest thing. We're going to use our default setting. Our default setting as humans is to think linearly. So I'm just going to connect these 2 points with a line and find the slope of that line. So I want to know what's going on at 2. When in doubt, connect the dots. This fits our description. It's decreasing and it's differentiable, and it's the easiest thing we can do. So I'm just going to calculate the slope between these 2 points. We ended up at 950. We started off at 1190. X ended up at 3 and started off at 1. So negative 240 over 2, negative 120. Now, an important part of this is we want to interpret what's going on. We need to include the units. Now, I didn't leave space because I wasn't planning ahead. Pretty difficult, but the 950 and the 1190, those are both in liters per hour, and we're dividing by the 3 minus 1. The 3 and the 1 are both in hours. So up on the top, we have liters per hour. We have liters per hour, and in the denominator, we have hours. The only reason we can subtract the 950 and the 1190 is they have the same units. We can add and subtract things when they're the same, and in this case, that means the same units. So we're decreasing by 240 liters per hour over 2 hours. So that's decreasing by 120 liters per hour per hour. A lot of times we abbreviate this as liters per hour squared. liters per hour squared is liters per hour per hour. It's how the rates is decreasing. When we have to make stuff up to estimate, just use the simplest thing that makes sense. That is connecting these with a line. So this means that the rate at which water is being removed from the tank at 2 hours is decreasing by approximately 120 liters per hour per hour. This ignores the parentheses part, but there's parentheses around the liters per hour per hour. Any questions? Now we'll do the same. We could use the same approximation for R of 2. We don't know what's going on at 2. We know what's going on at 1 and 3. 2 is halfway in the middle, so we just figure out what's halfway between 1190 and 950. So for R of 2, we'll continue to think linearly and just find the average of R of 1 and R of 3. Figure out what's halfway in between. So adding that up is 2140, and then divided by 2 gives us 1070. At 2 hours, the water was being removed from the tank at a rate of 1,070 liters per hour. In both of these problems, we're thinking linearly. We're just drawing a line between the 2 points on either side of the hour we're interested in. We're still thinking linearly. If we make the tangent line, or if we create the line connecting 1190 and the 950, this is the same place we will land. So this is still thinking linearly. So if I create the tangent line, if we start at 1190 and decrease by 120 whenever x increases by 1, oh, it's t. So here, the rate is 1190 when t is equal to 1, and will decrease by 120 liters per hour. And then we can just evaluate this at 2. So this says start off at 1190 and subtract 120 one time. This is thinking linearly. This is just drawing a straight line between the 2 points that we have. Questions? One of the tricky parts of this problem is that the t values are not evenly spaced. So in the first, here we see a decrease, and then from 1190 to 950, we see a decrease of 240. But that was over a 2-hour time span, whereas the 1340 down to 1190, that was over a 1-hour time span. So we can't just look at the differences. We have to look at the differences. We can't just look at the change in R. We also have to look at the change in T. Also, since R of 2 is just we're just filling in a value for that should appear in the table, the unit should be liters per hour. Notice that the units of 1190 and the 950 are still liters per hour. There are no units on the 2 because that's just saying add these two numbers and divide by the two numbers. So the 2 is not 2 hours. This is just no units. That's just saying there are two values that we're finding the average, and that's how we're finding the average. Any questions? Is everybody okay? Everybody looks super stoked. Y'all look like this. Like writing all these problems that might show up on the final. Y'all like, oh, one thing I do want to point out, I made kind of a not a great choice. I should have centered this problem around 4 because 4 is not exactly is not halfway between the 3 and the 6. So if we, for example, redid this problem around 4, once again, we don't know what's going on at 4. Presumably it's something different, so I'll use a different number of question marks. Now notice that here, instead of being 2 being exactly between 1 and 3, 4 is a third of the way from 3 to 6. There's 4, 5, and 6. So we're dividing the 3 to 6 up into 3, and we want that first 1/3. Now, if I wanted R prime of 4, that we could still just get with the slope between 3 and 6. I'm just going to write it down here. 740. We ended up at 740 minus 950 divided by 6 minus 3. I'm not going to be able to calculate this. 740 minus 950 is 210. 6 minus 3, I hopefully don't need a calculator for that, is 3. So we're decreasing by 70 liters per hour squared. Liters per hour per hour. That's just connecting the 950 and the 740 with a line. The reason we were able to calculate R of 2 using the average of R1 and R3 is that 2 is halfway between R1 and R3. Notice that R of 4 is not halfway between R of 3 and R of 6. So we don't want an average. We need to go 1/3 of the way through. So notice that R of 4 is not the average of R of 3 and R of 6. Four is not halfway between 3 and 6. The reason that I'm pointing this out is that yesterday it was a lot of you just found the average of the 1190 and the 950, which is a perfectly valid way to do things because the 2 was halfway in between. In this case, I would want to use the equation of the tangent line, or we could just think I'll subtract 70 one time. So those are actually the same thing. So if you're just, I'll just subtract 70 one time, because it's 70 per hour. From 3 to 4 is 1 hour. We'll subtract 70. So R of 4, to do R of 4, I'll take, say, started at 950 at 3, and subtract 70 one time. 950 minus 70 is 8 negative 20, or 9 negative 20, so 880. Approximately. If you're not sure that you like this, I'm just doing the tangent line thing, just writing a different tangent line. So now I'm looking at the point here at 3,950. And this point here at 6,740. We're still going to connect these with a line because that's the easiest thing to do. That's the default setting for how things change. But now instead of wanting a point halfway in between, I want a point third of the way in between. There'll be another point here at 5, where we subtract another 70. And then 6, 740, we could subtract another 70. 11 minus 7 is 4. We could also build the tangent line from these 2 points. Because our denominator is 1, it's a lot less important because we're just subtracting big round numbers. But if we build the tangent line, we start off at 950 and decrease by 70 whenever t changes from 3. So there's our tangent line. And if we evaluate the tangent line at 4, there we are, starting at 950 and subtracting 70 one time. Questions? I messed up putting the problem at 2 instead of writing the problem around 4. Is everybody okay? So in all these cases, we were thinking linearly. When you just found the slope of the line between the 2 points, you found the slope because I said find r prime, and you said derivative means slope. Goes back all the way to the first day. Derivative is the slope thing. I'm looking at 2 points, and the point that I care about is in between those 2 points. So I'll just calculate the slope between those 2 points. It's the best we can do. Is everybody okay? We can also think linearly when it comes to calculating the area. So notice that I haven't done the area question. The area question was the definite interval from 0 to 8, and then what does it mean in this situation? So let's do that. I don't think it'll fit. So to calculate the integral from 0 to 8 of r of t dt, first thing that we'll want to do is think about the units. R of t is liters per hour. dt is measured in hours. So if I multiply these things, our result is going to be in liters. These are just the units of the definite integral. We still have to interpret what that is. We're integrating the rate of change. It's going to be the change in the amount of water. Liters per hour is the rate of change of water with respect to time. I multiply that by time. I get the distance, or in this case, the number of liters. So this is the amount of water that is pulled out of the tank. There's like a few stages going on here. That's why I asked the question in stages. Include units with your answer. They're liters. We got that just by looking at what we were doing. R of t is liters per hour multiplied by dt, which is in hours. The hours cancel. We're left with liters. We've figured out what the units are. In the context of this problem, R of t is the rate at which we are removing water from the tank. So this is going to be the amount of water we remove from the tank over this time period for 8 hours. In California, we're like, oh, where is this 50,000 liters of water? We need to get our hands on that. I'm not even sure that that's a lot of water. How much is 50,000 liters of water? How big of a pool would that be? Right now, my math is showing. I did this in Calc 3 the other day. I had a problem where you calculated the electrical charge in coulombs, and it was like 88, and apparently that's a lot. Some students were like, oh, well, that seems like too much. How am I supposed to know? That's a physics question. I just needed like electrical density is a charge density is a thing. Well, shit, we'll multiply charge density by area. And then I thought about it for a minute. The area of the plate over which the charge was distributed was also like bigger than this room. So I'm just like throwing stuff out there. It's like when I do voltage, current, and resistance. Like as a math problem, the answer might be like 6 amps. And like all the electricians are like, oh, holy shit, this problem is deadly. Get a bigger resistor. Do you know what I mean? What are we talking about? Oh, yes. So we got to calculate the area from 0 to 8. And we saw a few different approaches. I'm just going to draw kind of a quick and dirty map here. So 0, it's a 1, a 0, and then 1, 2, 3, 4, 5, 6, 7. So all we have for information is these 6 points. But we already know what we're supposed to be doing. We're supposed to be calculating area, and we can apply our default mode of thinking which is to think linearly. So there are a few ways that this can show up. I want to talk about some of the So one thing that we could do, we could think from 0 to 1, we started off with, actually, that's the second part of the problem. If we want to integrate from 0 to 8, I could say the area from 0 to 1, I could just use the highest value and just use this 1390 for everything. Can't remember all the numbers. 1340. And my math is showing once again because I'm just like evenly spacing all these unevenly spaced values. So one calculation that we could do is just use 1340. So the integral from 0 to 8. One strategy that I saw was to say, just use 1340 for an hour. Then the next one, to use the 1190, using 1190, we could add 1190, but we'll do that twice. Because that would just go straight across. Go straight across. And then use the 950 3 times. And then use the 740 twice. And actually not use the 700 because that's where it ends. We end at 8. So there are 1, 2, 3, 4, 1, 2, 3, 4, and we're just imagining them as rectangles. This is going to give us an overestimate of the actual area. And I actually wrote this down. This is going to be 8,050. And we know that this is in liters because we did our unit analysis. This is an overestimate of our integral from 0 to 8. I'm just taking the largest value that I know of on this interval and using it for the entire interval. This first term seems to be missing something. So with this first term, we could read as 1340 that I'm using for 1 hour. And now all the terms look like a liters per hour multiplied by hours. Liters per hour multiplied by hours. Liters per hour multiplied by hours. But it didn't show up in here as much because I just wrote 1340 because I multiplied by 1. That's because I took 1340 and used it for 1 hour. Here we get an overestimate because we're using the largest value that we know on each of these intervals. We can also calculate this with we can underestimate this. Instead of the largest value on this interval from 0 to 1, I can use the smallest value. I take the 1190 and use that 1 time. And then the 950 and use that twice. And then the 740 and use that 3 times. And then use this 700 for the last 2 hours. So largest value for our overestimate, smallest value for our underestimate. And this will give us an underestimate. I got, what did I get for this? 6710. So depending on what this function actually looks like, we expect the actual value to be between 8,050 and 6,710. So based on these data, we have a lower and upper bound of the actual definite interval. That would be the best that we could do with this data. So since we have the actual value somewhere between these two numbers, and since we know there's no funky business going on because we were told that the function is decreasing and differentiable, it's reasonable to just find the average of these two values. So we might say that the integral from 0 to 8 of r of t to t is just the average, 80/50 and 67/10 divided by 2 is 73/80. And that's still going to be measured in liters. The 80/50 and the 67/10, those are both measured in liters. We're just dividing by 2 because we're finding an average, so there are no units down here. Now, if you recall, on the first two problems, I said when there's doubt, just use the simplest thing. Think linearly between all the things. And that's the area that we have with this 73/80. This is the area if I just draw a line between all the points that I know. So this is still thinking linearly. If I just draw a line, connect all the points with a line, if I connect all the points with a line, we'll find the area of all these trapezoids. That's just the average of and a trapezoid is just the average of the two rectangles that contain it. So by finding the average of our overestimate and our underestimate, we are still thinking linearly. This is still our default mode of thinking. Whenever we calculate the average by adding up the numbers and dividing by 2, we're just connecting those 2 points with a line and picking the point halfway in the middle. We are splitting the difference. Any questions? The area of a trapezoid will be the average of the areas of the rectangle, the two rectangles. The area of a trapezoid is just the average of the areas of two rectangles. So if I've got, I'm just going to draw it in the orientation that we. The dimensions in a trapezoid are two bases and a height. The area of a trapezoid is 1/2 B1 plus B2 times H. The 1/2 B1 plus B2 is the average of the two bases, and then H is the height. And this is the average of two rectangles. One of the rectangles is this smaller one, which is B1 times H. And the other rectangle is this larger one with a height of B2. I guess I should say a width of B2. That's B2 times H. And we want to add these up and divide by 2. So the area of a trapezoid is the area of a couple of rectangles. We're just connecting the two rectangles with a line. This works even if the bases are, even if the height is not actually one of the sides of the trapezoid. So just take this one, like knock it over, and then like dent in one side. So bend it one, shove it over. Area is still the same. Any questions? Is everybody okay? Everybody looks super stoked. Got to do some geometry. Does everybody remember area of a trapezoid? You pretend that you do, because it's not. That's one of the fun parts of being in math classes, especially at this point in your mathematical career. We'll say things like, hey, do you remember, and then name something from one of your previous math classes. And for the most part, the answer is no. And then some teachers are like, oh, well, I guess we'll just have to just do that now. I'll just remind you. So if I'm like, oh, remember double angle identities from trig? I'm like, I know that the answer is going to be no. So I'm just going to tell you, it's like, oh, here's what we need, double angle identity from trig. And then some teachers like use that against you to make you feel bad for like not remembering everything from the previous like 12 years of your schooling. I mean, really? You expect me to remember shit from high school, trigonometry class, where they might not have even told me what the double angle identity is more than once? Do you know what I mean? It's just unfair. Some teachers are out there to make you feel bad about yourself. Don't let that. Some teachers just be mean. the screen dimmer today than normal? Or is it always this dim, or am I just like dim today? I definitely feel dim, so I like look at the screen. It doesn't seem very bright. I'm like, well, I'm not very bright, so maybe that's what it is. I don't think that. Maybe you hadn't noticed, now you do. You're like, oh, you had to fucking say something? Because now I'm trying to figure it out. All right, so this was a different kind of problem than we had. So instead of giving you a function, instead of giving you a full graph, I gave you kind of pieces of a graph. And I left off some details. And I said, what details are you going to make up? Yesterday it was about me observing what details would you make up? And you all made up the same details because it's the default setting. So you just had mathematical instincts kick in. It's like, oh, I'm just going to make lines. Whether you thought you were making lines or not, whether you thought you were thinking linearly or not, you were thinking linearly. As soon as you calculated an average, as soon as you found the slope between those 2 points, you were thinking about lines. Not explicitly, but it was running in the background. Does that make sense? We're just trying to update your default modes of thinking. Because that's way more important than understanding all the details about what's going on in the background. You know what I mean? Like how many of you here drove today in a car with an internal combustion engine? Some of you might have electric cars. And how many of you can explain how that internal combustion engine works? Is it 2-stroke, 4-stroke? What's going on? How does that work? Doesn't matter. Press gas pedal, make car go. Press brake pedal, make car stop. That's all we need to know. Spin wheel, make car change direction. We don't even know how that works. How does your steering work? Do you have electrical power steering, or is it hydraulic? Or is it non-power steering at all? If it is, I'd like to see your car, because it would be cool. Everybody okay? There are some really cool cars in the parking lot. There's a red Pontiac Aztec. That's by far the coolest car on the campus that I see on a regular basis. Yesterday, I saw a first generation 3-door RAV4. I'm like, oh, that is a cool car. I guess I have a weird opinion about what a cool car is. Like if someone drove here in a Ferrari, I probably wouldn't think twice about it. Someone shows up in a fucking Pontiac Aztec. I'm like, oh, wow, look at that. There's also a first gen MR2. Someone's driving a first gen MR2. And it's really cool. And I can't find out who it is because it'd be weird. I'm like, well, hey, are you driving this car? And like, are you stalking me? It's like, oh, no, I'm stalking your car. And it's just weird. So I can never know. I don't get to know. There's also a 5 Series wagon on the parking lot. Right? Anyway, what are we talking about? Oh, yes. Your default mode of thinking, running in the background, you were thinking linearly. And here is the calculus behind you thinking linearly. Thinking linearly is us taking stuff that's changing continuously and just saying, nah, lines, and just breaking it up into a bunch of lines. That's what's running in the background. Four-stroke engine, by the way, unless you rode here on a small motorcycle. That's it for today. I will see you all on tomorrow. But have a good day, and thanks for playing. Oh, there's a sign-in sheets.